So hello everyone. Welcome to today's session. So in the last session we were discussing about the partial fraction problems, and we have discussed few important problems. So we are going to solve one more problem in this session. After that we are going to go with the next concept. Okay. So now look at this problem. So here in the denominator we can see that this is not in the form of partial fraction. So how partial fractions question would be z minus 2 into z minus 4, like that, right? This is not in that form. This is in the form of z cube minus 5z square plus 8z plus minus 4. So here we need to use the synthetic division in order to find the roots of this equation, so that we can write it in the form of partial fraction. Okay. So now we need to find the synthetic roots. Okay. Plus 8z minus 4. So here now we need to compare its coefficients, write all its coefficients in one side, 1, minus 5, 8, minus 4, along with its first root. That is, the first root is, we need to put this equation in the calculator, or we can even substitute these values of z such a way that we need to get this term is equal to 0. If we need to put the value of z in such a way that if you put the value of z, we need to get it as equal to 0. So I have already done that. So if we put this equation in the calculator, and if we get the answer as 0, the term which we need to substitute for z is 1. That term we need to write it first. That is, so this is your first root. Okay. Now from this first root we need to find the other two roots. So what we should do here is, this first one is there, right, as it is, bring it down here, right here. And now we have this 1, right, we need to multiply with this 1. So 1 into 1 is 1, write it here. Again we need to add these two terms, minus 5 plus 1 is equal to minus 4. Again multiply 1 with this term, 1 into minus 4, minus 4. 8 plus minus 4 is equal to 4. 1 4 is of 4. 4 plus 4 is equal to 0. We need to do this synthetic division in such a way that the last term, whatever we get, right, by adding, it should be equal to 0. It strictly should be equal to 0 in order to get the roots. If it is not equal to 0, you might have done some errors. You might have done some mistake. This should be equal to 0. So now we have the three coefficients. In this we can write one quadratic equation. So let's start from 1. If we consider 1, it becomes z square minus 4z plus 4. Okay, these are the coefficients. I have written it in the quadratic form. So now in order to find the other two roots, we need to use the quadratic formula, that is z equal to minus b plus or minus square root of b square minus 4ac divided by 2a, right? So the same thing we are going to do it here also. Minus of minus 4 is plus 4 plus or minus 4 square, minus 4 whole square is 16, minus 4 into 1 into 4, that is 16 divided by 2, that is equal to 4 plus or minus 0 by 2. So 4 by 2 is repeating again, so we need to the two roots which we get is 2 and 2. So the three roots we get here is 1, 2 and 2. So now again we need to write this given question in this form. That is, we got the three roots, right? So that is z minus 1 into z minus 2 into z minus 2, or we can even write it as 4z square minus 2z is equal to z minus 1 into z minus 2 whole square. So now this is all the form of the partial fraction. So now for this we need to apply the partial fraction rule and find the values for a and b. Okay. So now let's apply the partial fraction rule for this one. So it becomes a z into z minus 1, since there is a z minus 1, plus b z into z minus 2 plus c into 2z, az, right, since we are writing z minus 2 whole square. Let's take this as equation star. So in order to cancel the denominator, we need to take the LCM. So let's take the LCM here, az, since there is already a z minus 1, so we need to write it as z minus 2 whole square, since this term is missing, right? Whichever term is missing, that we need to write it, okay, in the numerator. So here we have z minus 2, but z minus 1 and another z minus 2 term is missing, plus 2cz into, we have z minus 2 whole square, but z minus 1 is missing. Z minus 1, z minus 2 whole square. So we can cancel these two terms. 4z square minus 2z is equal to az into z minus 2 whole square plus bz into z minus 1 into z minus 2 plus 2cz into z minus 1. Here again take z common in both left hand side and right hand side. So take z common here, so the remaining term is 4z minus 2. Here also take z common, a into z minus 2 whole square plus b into, take z, we have taken z common, so z minus 1 into z minus 2 plus 2c into z minus 1. So that we can cancel this z. So the remaining terms are 4z minus 2 is equal to a into z minus 2 whole square plus b into z minus 1 into z minus 2 plus 2c into z minus 1. So take this as equation 1. So now here we need to find the values for a, b and c. So here the same thing. In order to find the value of a, we need to make these two terms equal to 0. We can make these two terms equal to 0. See we have z minus 1 and z minus 1. If you put the value of z as 1, these two terms will be equal to 0. We can find the value of a. Similarly, we can find the value of c as well. See here, in order to find the value of c, we need to make these two terms equal to 0, right? We have z minus 2 term common for both the terms. That is, we can put the value of 2, z as 2, and we can cancel it in order to find the value of c. But we can't find the value of b here. See, here we have z minus 2 and we have a z minus 1. So we cannot put substitute any value of z in order to make these two terms equal to 0. So for that case, we have done it in our previous problem in our last session. That is, we need to compare the coefficient of the highest degree. So here the highest degree in this equation, we can see it as it is z square. So here again, in order to find the value of b in this equation, we need to compare the coefficient of z square. So in order to compare the coefficient of z square, we need to first split this equation, right? So let's write the splitted equation so that we can solve. So the splitted equation would be like this: z minus 2 whole square, use the identity, we get it as z square minus 4z plus 4 plus b into, let's multiply this, z square minus 2z minus z, so that is equal to minus 3z plus 2 plus 2c into z minus 1. So this equation is required for us to calculate the value of b. But for now, let's keep it aside, and in this equation we will first find the values for a and c. Okay. So in order to find the value of a, we need to put the value of z equal to 1. Okay. So the left hand side becomes 4 into 1 minus 2. 4 minus 2 equal to 2. A into 1 minus 2 whole square plus b into 1 minus 1 into 1 minus 2 plus 2c into 1 minus 1. So here these two terms will become 0, right? 2 into a into 1 minus 2 is minus 1 whole square. So 2 is equal to minus 1 whole square is 1. So therefore we get the value of a as 2. Okay. So similarly, let's find the value of c. So in order to find the value of c, we need to put the value of z equal to 2. Okay. So the left hand side becomes 4 into 2 minus 2. So 4 into 2 is 8. 8 minus 2 is 6 is equal to a into 2 minus 2 whole square plus b into 2 minus 1 into 2 minus 2 plus 2c into 2 minus 1. So here we can see that these two terms become 0 since there is 2 minus 2. It is 0, right? So 2c into 2 minus 1 is 1. So 6 is equal to 2c. Therefore c is equal to 6 by 2. C is equal to 3. So now we have found the values for a and c. So now as I have told, we need to compare the coefficient of z square in the equation that we have written here. Okay. In order to find the value of b. So what we have written the equation? The equation which we have written is 4z minus 2 is equal to a into z square minus 4z plus 4 plus b into z square minus 3z plus 2 plus 2c into z minus 1. In this we need to compare the coefficients of the highest degree, that is z square. Okay, so here there is no z square in the left hand side, so it becomes 0. So here we can see that the coefficient of z square is 1. If we multiply a, the whole term, so we can write it as the coefficient of z square as a. In this the coefficient of z square is b, and here there is no z square term, so 0 is equal to a plus b, and 0 is equal to, we have already find the value of a, that is 2. So let's substitute that 2 plus b minus 2, bring this 2 to the other side, is equal to b. Therefore by comparing the coefficient of x square, we get the value of b as minus 2. So now we have found the values for a, b and c. So now we need to substitute these all values in equation star. So this is your required equation star. Okay, substitute the value of a, b, that is minus 2, it is plus of minus 2, right? So I have written directly minus 2 plus 2 into c, it was 2 into c, right? 2 into 3. So now take the z inverse, take this 2 outside, so it becomes z of z minus 1 minus 2 into z inverse of z divided by z minus 2. But we have here z minus 2 whole square. Okay, here we can see that it is whole square, but the identity says that it is a z divided by z minus a whole square. We have only z minus 2 whole square. We need to have here this as 2. Okay, so we have 1 2 outside, right? So bring that 2 outside to the inside term, so that it becomes, let these 3 remain outside as it is. In order to satisfy the condition, let's write it as 2z divided by z minus 2 whole square, so that we can direct the z inverse. Okay, so now let's write z inverse of z by z minus 1 is equal to 1, right? Minus 2 into z inverse of z by z minus 2 is equal to 2 power n plus 3 into 2 power n into n into a power n, right? Yeah, so the required final answer is 2 plus, take this 2 power n outside, common, right? 3n minus 2. So this is your required z transform of this question. Okay, so we have solved I guess 4 to 5 problems we have solved related to this partial fractions. So you have to be clear about this. I have solved this in very detailed manner so that you can understand. Okay, this partial fraction concept is very important. I guess nearly 2 problems might be asked in this partial fraction concepts. Okay, so we have one more topic left in this Z transform, that is solving the differential equations using inverse Z transforms. So we'll do that and we'll wind up this session. Okay. Okay, so this is the last topic of this module of this chapter, that is of inverse Z transforms, that is application of differential equation. So we are going to be having a differential equation. From that we need to get the value of u of z such a way that we can use the Z transform and solve the problem. Okay, so here is a procedure about how to solve. So I am just going to read it out. So if you didn't understand, surely during the time while we are solving the problems, you will understand it. Okay, so now let's I'm going to read this procedure out for you guys. Okay, so the application of differential equation says that the solution to given difference with constant coefficient using Z transform. So the procedure is, we need to take the Z transform on both the sides of the given differential equation. So you will be given a differential equation. In that differential equation would be of the form of some initial final value conditions which we have learned, that is u of n plus 1, u of n plus 2. In that way, how a differential equation would be generally, it would be of the form d square y by dx square, that form, right? But in place of that, now we have u of n plus 2 and u of n plus 1, u of n. is equal to some constant term. Okay. For that we need to take the Zen transform on both the sides. After that we need to use the left shift property for simplification. Okay, we have written few properties for left shift, right? That is for to find the values for u0, u1 and all. Okay, then transpose all the terms without u of z to the right. So after that, whatever u of z term will be remaining, right, that we need to, in a differential equation, u of z term would be constant for all the terms, that we need to take it outside and we need to write the remaining variables, and after that we need to bring u of z to one side and all the other terms to another side, so that we'll get the term u of z there. Okay, so that is the next step, that is we need to divide the coefficient of u of z, so that we get u of z is equal to something. Okay, that would be of the form of partial fraction. Okay, then after that the same thing procedure remains the same as we have solved for partial fraction, that is we need to take the z inverse on both the sides and we need to find the value of u of z. Okay, so this is the brief procedure of an differential equation. So during the problems you will get to know about them. Okay, so let's wind up this session. So in the next session, that would be a last session for this module, we are going to solve the problems related to we are going to solve 3 problems related to this differential equations, so that you will be clear about this concept, and this Z transform module will be completed. Okay, so that's all for today's session. Thank you. We'll see you at the next session.